Hey everyone, I'm Mukesh from CodeWithMukesh.com, and in this video, since I just completed upgrading my FullStackHero .NET Web API project to .NET 7, I just thought I'll make a quick video about it, regarding some basic overview, how you'd set it up using the new CLI tool, and how you'd get started with this boilerplate. FullStackHero Web API Boilerplate can be a starting point for your next Web API project. It comes with several built-in features like Serilog, identity management, Hangfire, custom middlewares, mailing, multi-tenancy, entity framework core, mediator, SignalR, API versioning, fluent validations, audit logging, switchable database providers including PostgreSQL, MS SQL, MySQL and Oracle, Mapster for DTO mapping, advanced user and rule management, and so much more. And as for the deployment side of the API, the boilerplate comes with Docker support, wherein you already have the required setup and scripts for building Docker images and pushing them to Docker Hub directly. Docker Compose file examples are also available. And for cloud deployment, I have included Terraform scripts to provision resources into the AWS infrastructure like ECS clusters, CloudWatch log groups, RDS instance with PostgreSQL engine, and finally, it also comes with some makefile commands, which is going to be a serious improvement in the productivity of developers. Overall talking, this project can really save you hours and hours of development time so that you can quickly jump into writing business code rather than worrying about the architecture or deployment needs. First up, let's jump into setting up the development environment. So here is what all you need to configure in your system before working with this boilerplate. Ensure that you have downloaded and installed the latest version of .NET 7 SDKs and runtime on your machine. And as for the IDEs, you can choose your favorite one like VS Code or Visual Studio. I have used both of them during the development of this project. For databases, the project currently supports PostgreSQL, MS SQL, MySQL and Oracle. By default, the project comes pre-configured with PostgreSQL connection strings. Make sure that you have installed your choice of database servers. And if you're interested in Dockerizing your application, ensure that you have the latest Docker desktop installed on your machine. And as for API testing, you can either use the built-in Swagger, Postman or Thunderclient. So this Thunderclient is currently my favorite one as it can be accessed within Visual Code and it's pretty lightweight. Also, it has almost all the required features as Postman has. For cloud deployment, ensure that you have an AWS account handy. Even a free tier account would do. You'll also have to install the AWS CLI on your machine to authenticate into the AWS infrastructure. I have explained it in this video, please refer to it. Finally, you'll also need to install Terraform on your machine. I recommend using Chocolatey to get this installed as it's pretty easy. You can find the links of all the resources on the documentation website of FullStackHero. To get started with this boilerplate, there are multiple options available. The first one is to install the template in your machine using the FSH CLI tool, which I'll be showing in the next section. You can also fork this repository and clone it into your local development machine. After you have installed all the required SDKs and tools, you will need to install the FSH CLI tool. Open up a terminal and run the following command to install the CLI tool. This will install the CLI tool on your machine. Once that is done, simply type in FSH install command to install all the associated templates. So now that you have installed the template locally on your machine, let's see how you can start generating Web API solutions seamlessly using this tool. Simply navigate to a new directory wherever you want to place a new Web API solution and open up command prompt. Simply run this command FSH API new FSH.Starter. So this is going to be the solution name of my project, FSH.Starter. Once that is done, your solution is created for you. As simple as that. Here is a folder structure and files created for you. Alternatively, you can also use Visual Studio to generate the solution for you. Simply open up Visual Studio and click on Create a new project. Here, search for Web API. You can see the Web API boilerplate template here. You can use this to create a new solution. However, it is recommended to use a CLI tool for a cleaner experience. Next, let's run our API server. Open up the project in your favorite IDE, which in my case is VS Code. First, let's set up some valid connection strings. Open up source, host, configurations, and database.json. So these are the database settings that come pre-configured with the boilerplate. For samples of other connection strings, you can check this section of the documentation where I have included all the database connection string as a sample. Once the connection strings are configured, we'll just have to run a couple of make commands to build and run our application. Enter in make build to build the project. Once that's done, run make start to spin up the API. As you can see from the logs, our API server is now up and running on localhost 5001. So a couple of operations happen when you launch the application for the first time. The migrations that come out of the box with the template gets applied and the new database tables gets created for you. So you don't have to apply the migrations manually, the code takes care of it for you. And being a multi-tenant solution, the application is programmed to seed a default tenant named root that is basically the super admin of the entire application and has permissions to manage other tenants. Once the tenant record is seeded, the tenant admin, roles, and the permissions are also seeded. Apart from this, some dummy brand data is also seeded. The connection strings that you provided in the app settings will be taken as a root tenant's connection string. Note that all the tenant data will be stored on this connection string under the tenants table. So now that our API server is up and running, let's try to test our API and explore a couple of endpoints. You can either use a default Swagger UI that comes with the application at localhost 5001/Swagger for testing the application, use Postman, or use Thunderclient within VS Code. For your information, you can import the Postman collection from here. I'll be using Thunderclient for this demonstration. So Thunderclient is my personal favorite way to test any API that I work with. This will be helpful for you too if you use VS Code for .NET development. So make sure you have the Thunderclient VS Code extensions installed. Firstly, I'll show you around this tool. So here is where our request collections stay, and here are our predefined environments. So for my testing purposes, I have added local, ECS, and Docker. Let me open up local. And these are the variables in it. The main variable here is the URL, which points to the API, and the remaining access token and refresh tokens are quite dynamic. Firstly, know that the entire application is secured by JSON web tokens, and any endpoint will allow only authenticated requests. Let's start by generating a token for the root admin user. So you'll have to navigate to collections, .NET Web API Boilerplate collection, identity, and get token. So here if you see, we are passing the default credentials that we have created during the initial launch of the applications. And also it is important to note that at the header, we are passing a tenant ID as root. So once that is done, we'll have to go back to the body and send in the post request. If everything goes well, you'll get back the access tokens. Now you don't need to copy these access tokens and pass it to each and every request. I have already configured Thunderclient to do it for you automatically. So whenever a valid token is generated, it is stored as a variable of the environment and used by default for all the subsequent requests until the token is expired. So by default, the tokens have a lifetime of about 60 minutes, which is configurable via the security.json under the configurations folder that we saw earlier while setting the database connection strings. So now that we have a valid access token, let's explore the other endpoints of the API. Under identity, we can register a new user by sending this request, which will eventually send out an email to the registered user with a confirmation link. Let's test it out. So these are the request details, which includes the first name, last name, email, username, password, and phone number of the newly registering user. Let's post this request and switch to Ethereal to check if we get back the email. Now Ethereal is a fake SMTP service that we are using to mock emails. Navigate to messages and you can see that the registration mail has come. Let's open it up. Let's confirm it by clicking this particular link. This would confirm the user account and they'll be now able to log into our system. And apart from that, we have requests to get roles, create a new role, get permissions, get profile data, forget password, reset passwords, and so much more related to the identity management of the application. Next, let's switch to the catalog brands. So here, I'll try to get a list of brands that were already created. So I send in the request and you can see that these were the particular data that we had added during the launch of the application. You can also see that we are getting a paginated response. And you can use the keyword property to filter out the response. For example, I'm typing in MSI and sending out the request. So here you can see that the data is filtered out. Similarly, we can also create brands using this particular request. So by sending the request and I get back the ID of the newly created brand. Let me copy this for future use. And apart from this, you can also delete that particular brand and also update the brand. Next, let me switch to products and I search for products. So there are currently no products available in this particular catalog. So let me create one. I go to create product and I will copy paste this particular brand ID from the one that we created earlier. And let me send in the request. And from here you can see that this particular product has been created. Let me copy this ID as well and use the get by product ID and search it here. Let me paste it here and I send out the request. As you can see, this is our product that we created earlier. And here as well, you can delete the product and update the product. Next is the core feature of this boilerplate, multi-tenancy. Let's open up the multi-tenancy requests. So only the root admins have access to these sets of endpoints. From here, I can get all the tenant in the system, which is currently just one, the root. Let's create a new tenant named beta. So let me open up the create tenant. Here, since the connection string is empty, the new tenant will share the database of the root user. Soon as I send out the request, the default data of the new tenant beta will be seeded along with new admin users of beta tenant. Now, let me send out the request. As you can see, we have seeded some data for the beta tenant and it's showing up in the logs as you can see. Now, when I run the get all request, I'll be able to see the new beta tenant coming up here. So we also have provisions to deactivate and activate a tenant. So let me deactivate the beta tenant. So I click on this deactivate request and here you can see is the tenant ID and I send out the request. So here if you see, the beta tenant is activated. Let's go back to the get all and send out the request again. Here as you can see, the isActive flag is set to false now. So now let's activate back the beta tenant. I'll go to this activate tenant request and send out this request. So here you can see the beta tenant is now activated. Let's verify it once again using the get all request. I send out the request and now we can see that the active flag is set to true. If you see the tenant details, it has this particular property called valid up to, post which the tenant users will not be able to log into the system. You can also upgrade a subscription of each of the tenant using this particular request, that is upgrade request. So I send in with the tenant ID as beta and I can set a particular extended expiry date and I send out the request. So here you can see the message that comes back, tenant beta subscription upgraded. Now it's valid till the new particular date time that we had passed in the request. That's it for the API testing. Now let's examine the project structure of FullStackHero. Let me zoom in a bit. As mentioned earlier, this project uses clean architecture principles. The entire solution is built in such a way that it can be scaled and maintained easily by teams of developers. The solution primarily consists of the following projects, which is the core, host, infrastructure and the migrators. Under the core folder, we have the application, domain and the shared projects. So the idea is to build a very loosely coupled architecture following best practices and packages. Let's see in brief what responsibilities each of these projects handle. The host project contains the API controllers and the startup logic including ASP.NET Core container setup. This is the entry point of the entire application. Also, other static files like the logs, localization JSONs, images, email templates, and most importantly, the configuration related files live in this particular project. So for better management, the app-settings.json is further split into subsettings like database.json, security.json, and so on for better modularity and organization. You can find these new JSONs under the configurations folder of the host project. Next is the application project. This is one of the projects in the core folder apart from the domain and the shared projects. Here, you get to see the abstract classes and the interfaces that are inherited and implemented in the infrastructure project. This refers to dependency inversions. Also, the folders are split at the top level feature-wise, meaning it now makes it easier for developers to understand the folder structure. So each of the feature folders, like the catalog, products, will have all the files related to its scope, including validators, DTOs, interfaces, and handlers within itself. Thus, everything related to a feature will be found directly under that feature folder. Next is the domain project. So all the entities live here. Note that the domain project does not depend on any other project other than the shared project. As per the clean architecture principles, the core of this solution, that is the application and domain projects, do not depend on any other projects. This helps achieve dependency inversions. Now we have the infrastructure project. So this is where you'll be able to see all the implementations of the project. That includes the caching, for example local cache and the distributed cache, which are a part of the implementation. You can also add your own implementations here. For other examples, we have the mailing, which currently uses the SMTP mail service and which you can switch to maybe SendGrid or something. And then for logging, we have Serilog, and you can further extend this using nlog or something else. And finally, we have the migrators. So this particular project folder has multiple projects containing database related migrations. Let's also examine the various other folders in this particular solution. Firstly, we have the Docker Compose, which contains all the Docker Compose files, which we'll be seeing in the next section. Next, we have the Postman, where you can find the collection which you can import for testing purposes. And finally, here are the Terraform scripts, which I will explain later in this video. So this is going to be very interesting. Before that, if you haven't already subscribed to my channel, please do it, and also leave a like for this video. It helps me to stay motivated and build such open source projects. FullStackHero being .NET 7 is configured to have built-in support for containerization. That means you really don't need to have a Docker file to containerize your Web API application. So you can just modify the metadata of the Docker image from the host project. So you can find that under source, host, and you can open this host.cs project file, and here you will find these property groups. So here you can rename the image names and the image tags. So these are default values given by the template. To build a Docker image, all you have to do is ensure that Docker desktop is running on your machine, and you will have to run the following command, which goes by make publish. So this will build and publish a Docker image with the given image name and tags onto your local instance of Docker desktop running on your machine. Here you go. You can use these images to test your applications locally. Apart from Docker, we also have Docker Compose files with which you can spin up Web API and database instance in your local containers with some simple make commands. So you can find these commands in the documentations as you see here. This will boot up the Web API and PostgreSQL containers by pulling the Docker images hosted at Docker Hub. There are also examples for MySQL and MS SQL variations of the Docker Compose files. So you will be able to find the Docker Compose files under the Docker Compose folders here. So this is related to MS SQL, MySQL and the PostgreSQL Docker Compose files. There is also a README file here for you to refer. Next comes the Terraform and AWS deployment. For this, as I mentioned earlier, ensure that you have installed Terraform on your machine, registered for a free AWS account and configured your AWS CLI profiles with valid access keys. You can get more details about this in this video. That's it, let's switch back to VS Code. Here, go to the Terraform folder. So there are two subfolders as you can see, backend and environment. The backend folder is internally used by Terraform for state management and locking. There is a one-time setup you have to do against this folder. So navigate to this folder and run a command against it. So I'll just open a terminal against it and I'll just run Terraform init. This will initialize the backend of this Terraform. So once Terraform has successfully initialized, you will need to apply the changes that are available in the Terraform scripts of the backend folder. So for this, we'll just run Terraform apply. So this would create the required S3 buckets and DDB tables for you in your AWS account. Once the Terraform backend is completed, navigate to the environment folder and here the staging folder. So this is where all the resource definitions are there. As you see, we have resources related to ECS, RDS, IAM and load balancers. Simply open up the terraform.tfvares file. You can modify the configurations like the Docker image name and so much more. Let's initialize the Terraform registry. I will open up the terminal here and again run Terraform init. So once that's done, let me apply the changes by using Terraform apply. This will make Terraform start provisioning resources into AWS as you see from the logs. Basically, a Web API container would be brought up which will pull the Docker image. In parallel, the RDS instance will also be created to which the container will connect to. The connection string of the RDS instance is dynamically built in the ECS file and set as an environment variable to the ECS service. This way, the Web API will be able to connect to the RDS instance. So this will take around 2 or 3 minutes for everything to get created. Once done, we'll get back the API URL. Let's copy this and go back to our Thunderclient. Here, navigate into environment and open up ECS. Here in the URL section, we'll paste in the API URL. Also, let's make this environment active. I'll just set it active. Now let's go to the collections, identity, get token and try to send in the request. Before that, let me zoom out a bit. Now let me send the request. There you go. This is our JWT generated by the container running on AWS. Let's also examine AWS to check the container and its logs. So I have opened up my AWS management console and navigated to Amazon Elastic Container Service. So here as you see, we have the cluster named FullStackHero created. Let me open it. And under that particular cluster, we have one service called .NET Web API. So as you see, the status of the .NET Web API is active and there are no tasks failing. Let me quickly see the logs of this particular API. Serilog has logged all the messages in a JSON format. To view it better, let's open up CloudWatch. Let me navigate to the log groups. And this should probably be the log group that we write into. Let me open it, search log groups, and as you can see, these are the entries by Serilog. So maybe as a test, let me open Thunderclient and pass in an invalid credential. So as you can see, the API returns a 401 unauthorized. Now let's switch back to CloudWatch to see the log. There you go, we have the authentication failed message along with the stack trace and all the other parameters within the log context of Serilog. So once your testing is completed, do not forget to destroy the Terraform resources to avoid any unnecessary costs accumulated. So go back to VS Code and run the Terraform destroy command. This will completely remove all the AWS resources that has been provisioned by this particular version of Terraform. The Blazor WebAssembly also works seamlessly with this API. I'll just show around few sections of the client application. Let me first fill in the admin credentials and log into the application. So once logged in, I get to see the dashboard, which has the data related to the products, brands, registered users and roles, the account settings, where this is my particular profile and I can upload my own photos. Let me try to find a photo. It gets logged out and I will have to log in back. And as you can see, the profile photo is updated and you can see the logs. These are the audit logs that I had mentioned earlier, and you have the catalog management, that is the product and brands. Let me open up products. This will be listing all the products that is available for this particular tenant, and you will be able to edit and delete it from here. And in edit, there is already a photo here. You get a chance to view the photo, and let me close up the photo. I'll close this. Similarly, you can also create and edit brands here. In the administration section, which is available only for the admins, user management, role management and tenant management is also available. The tenant management is only available for the root admins. From here you can manage all the tenants. So as you remember earlier, in one of our API testing, we had created this particular tenant called beta. And there are other part of this client where you can customize the UI by the dark mode. You can set the primary colors, secondary colors, border radius, tables customization, everything else. Let me go back to home, and and also you can switch the UI language. For example, when I switch to French, the application loads the localization constants for the French language. Let me switch back to English. And that's it. Let me log out of this particular client. So for details about using this client, you can refer to this particular documentation where everything is clearly mentioned. Also, you can use this particular repository to get started with the Blazor client. Here is a documentation website for all the projects under FullStackHero handle. It is sorted by the project like API, microservices and Blazor. Let me know in the comment section below if you're interested in the microservices boilerplate. You can connect with me on LinkedIn as well, where I post almost 2 times a week about tips and articles for .NET developers. You can also follow my Facebook page for regular updates. And do not forget to star this repository. So currently we are at around 2800 stars. Help me reach at least maybe 4000 stars. And you can also support me by buying me a coffee, which will help me make more time for open source projects. That's it for this video. Hope you liked the FullStackHero project. Let me know in the comment section below if you have any feedback or suggestions for this project. Until then, thanks and see you in the next video, guys.